Hello there, math friends. Today we are taking a look at Topic 1, Lesson 6 in Intensified Algebra. And we're going to start off by just jumping right into the number line. Now, if we look at this number line, we can see that the numbers 1 and -1 have the same absolute value. You're like, well, what does that mean? 1 and -1 have the same absolute value. Well, the absolute value of a number is defined as its distance from 0 on the number line. So to go from 0 to -1, that's 1 unit on the number line. To go from 0 to 1 on the number line, it's 1 unit. And so each of those numbers, -1 and 1, both have an absolute value of 1. And in the same way, 3 and -3 have the same absolute value, because to get from 0 to -3, it's 3 units away. To get from 0 to 3, it's 3 units away. So absolute value is a number's distance from 0. An absolute value always has a positive value, no matter what. So when we talk about absolute value, we put these absolute value bars around a number. So this says the absolute value of -1 equals 1. The absolute value of 1 equals 1. The absolute value, with the great bars there, -3, the absolute value of -3 equals 3. The absolute value of +3 equals 3. Now, something else you should notice is that 1 and -1 are opposites, and taken together form a zero pair, as in like when you add +1 and -1, you get 0. If I give you $1 and then I take $1 away from you, you have $0. Zero pair, see? 3 plus -3 equals 0. So 3 and -3 are zero pairs. So for this reason, any pair of opposites is also called a zero pair, because they pair up to form a sum of 0. When you add them together, they equal 0. A million plus a -1,000,000 is 0. All right, so today's lesson, we're going to focus on the following goals. We're going to explore, apply, and share problem-solving strategies and reflect on solutions. We're going to work with important algebra ideas, including variables, patterns, and solutions. And today we're going to focus mainly on the idea of integers. Our core activity is this. The following are examples of what we're going to call square box problems. The patterns in these problems will be used throughout the course in different ways. Study the numbers in the different parts of the box and look for relationships. How are these numbers related? So in this first box, we have a 3, a 12, a 4, and a 7. How are they related? How about 8 and 16 and 2 and 10? How are they related? Similarly, -3, -15, 5, and 2. They're all related in some way, maybe the same way. So if we look at the relationship between the two numbers in the left and right parts of the box, and the number at the top of the box. So let's look at the left and the right. How are they related to the number at the top? Think about that. The left and the right, how are they related to the number in the top? Left and the right, how are they related to the number at the top? Think about that. Write down your answer. Pause the video if you must. And so, hopefully you discovered that 3 multiplied by 4 equals the product of 12. And 8 multiplied by 2 equals the product of 16. And you can assume that -3 times 5 equals a product of -15. Hopefully that's the relationship that you saw when you looked. Now let's try looking at it from a different way. How are the numbers related? How are these two numbers on the side related to the number at the bottom of the box? How are 3 and 4 related to 7? How are 8 and 2 related to 10? How about -3 and 5? How are they related to 2? What's the relationship of those two numbers and the bottom number in each of these boxes? take a moment, pause the video if you must. All right, thanks for trying that. Now, hopefully you recognized that 3 plus 4 is 7, 8 plus 2 is 10, and perhaps from that you can assume that negative 3 plus 5 equals 2. So, the left and right numbers relationship to the top number is the product of the numbers on the sides, and the left and right number, when you add them together, their sum is equal to the bottom number. All right, well, we're going to use the patterns that you discovered to complete the following square box problems. So give these a try, pause the video, and get back to me when you're done. All right, thanks for that. So if we do this in the exact same way as we did in the previous box problem, 5 multiplied by 7 would be 35, and 5 plus 7 would be 12. Hopefully that's what you did. Now, we don't know the number that's over here, but 9 times what number equals 18? Well, 18 divided by 9 would be 2. 9 times 2 is 18. And then 9 plus 2 would be 11. See? All right, now, this one's a little bit tougher. What numbers multiplied together equal 12, but when you add them together equal 13? Think about that for a second. Now, you probably noticed that 1 times 12 equals 12, and 1 plus 12 equals 13. That one was a stretch, probably. Now, the following square box problems involve some negative numbers, so let's use the patterns that you discovered to complete these square box problems. So what is negative 2 times 8? Negative 16, right? And negative 2 plus 8, well, that's 6. All right, how about negative 16? Now, these two numbers multiplied together equals 16, but these two numbers multiplied together equals 0. Oh my gosh. That would be 4 and negative 4, because 4 times negative 4 would be negative 16, and 4 plus negative 4 is 0. All right, now what two numbers, when you multiply together, equal 12? When you add them together, they equal negative 7. Well, I've got news for you. It's negative 3 and negative 4. Negative 3 times negative 4, a negative times a negative is positive, and that's positive 12, and negative 3 plus negative 4 is negative 7. If you got those, congratulations, pat yourself on the back. Let's keep moving. Now, do you play sports or a musical instrument? If so, think back to when you were first learning it. You probably needed to concentrate on some of the basic skills that go with it, and you probably developed some of those skills piece by piece through practice and hard work, right? Or, think about someone learning to dribble a basketball or hit a tennis ball. At first, it was probably not easy for that person. Even for someone like Serena Williams or Steph Curry, she or he had to concentrate and work really hard to develop that skill. They're highly respected professional athletes. After lots of practice, though, those skills became automatic. Now, of course, Serena Williams and Steph Curry don't have to think very much about hitting a tennis ball or dribbling a basketball. They do it without thinking because they don't have to worry about basic skills. They can concentrate on other more challenging aspects of their sports like passing, shooting the ball, or to aim their swing on the court. The same idea is true for learning math. It's important that you become automatic with certain basic math skills so that you don't have to spend a lot of time and effort on them. Doing so will allow you to free up your brain power as you work on more challenging math problems and ideas. Now, name a math skill for which you have automaticity. You have practiced it so much that you can do it without a lot of effort. And you can find this on page 38 in your math book, or whatever page goes with it in your math packet for topic 1, lesson 6. A skill that you can do automatically without having to think about it much. Could be anything. And then name a math skill that you don't yet have automaticity for, and you need more practice on it. Be honest, it's okay. That's why we take math classes, to learn math skills. Now, working with signed numbers, and that's positive and negative numbers, is one of the skills for which it's super important that you become automatic. You need to be able to look at signed numbers, positive and negative numbers, to add, subtract, multiply, and divide them and go, oh, I got this. Maybe you've already gained that automaticity. Maybe you already know it. But before we begin, let's review what we know about the set of signed numbers. Those are your positive and negative numbers. Now, the first numbers that you learned about in school were the numbers that you used to count with. These numbers are called counting numbers or natural numbers. Like 1, 2, 3, 4, 5, 6, and so on. Those are the natural numbers. When you add 0 to the natural numbers, this set becomes the whole numbers. So all you had to do is add 0 to that, and now they're the whole numbers. The natural numbers plus 0 makes the whole numbers. Now, if you take the whole numbers and all their opposites, that's the set of integers. Now, integers that are greater than 0 are called positive integers, and integers that are less than 0 are called negative integers. 0 is an integer, but it's not positive and it's not negative. It's what splits the positive and negative integers. So, mathematicians, scientists, engineers, social scientists all use models as a way to understand and explain abstract ideas. And so we like to practice things using models so we learn how and why they work. So we're going to practice adding, subtracting signed numbers using conceptual models to explain why the rules for adding and subtracting positive and negative numbers works. So let's take a look. Okay, so we're going to use this model to represent how to do this math. So this is negative 3 plus positive 3. Now I'm going to use red to represent negative 3. So 1, 2, 3 negatives. And I'm going to use yellow to represent positive 3. 1, 2, 3. Now, every time you have a positive and a negative, they're considered a 0 pair, right? So that means here we've got a 0 pair. So they're gone. They make 0. Here we've got a 0 pair. 0. Here we've got another 0 pair. 0. And when it's all said and done, what do we have left? We have 0 left. So negative 3 plus positive 3 equals 0. So let's take a look at the next one in your book and on this page. It's negative 5 plus positive 2. So negative 5. 1, 2, 3, 4, 5. And positive 2. 1, 2. Now, are there any 0 pairs? Match sets, a positive and negative. Yeah, here's one. Here's another. What do we have left? Well, we have 3 negatives left. So our answer is negative 3. Right? This is awesome. Let's try that again. Negative 2 plus 7. So negative 2 and positive 7. 1, 2, 3, 4, 5, 6, 7. Let's cancel out our 0 pairs. There's a 0 pair. There's a 0 pair. And what's left in our space? Well, we have 1, 2, 3, 4, 5. There are 5 positives left. So negative 2 plus 7 is 5. Now let's try negative 5 and negative 2. All right. 1, 2, 3, 4, 5. And negative 2. 1, 2. Are there any 0 pairs? No, because we don't have any blocks of opposite colors. So what do we have here? Well, we have 1, 2, 3, 4, 5, 6, 7. We have 7 negatives. So we have negative 7. All right. Let's keep going. Oh, this is interesting here. Now we're going to try a different conceptual model. This is the number line. Now, on a number line, we always start at 0. And in this one, this is negative 3 plus 3. So I'm going to start at 0, and I'm going to go to negative 3. Negative 1, 2, 3. Okay, that's where I'm at. And then to that, I'm going to add positive 3. So I'm going to move in the positive direction 3. 1, 2, 3. Where did I end? Well, I ended at 0. So negative 3 plus 3 is 0. Let's try that again with the next one. Negative 5 plus 2. starting at 0, always start at 0. 1, 2, 3, 4, 5. Negative 5. From there, I'm going to add 2. So 2 to the right. 1, 2. Where am I? I'm at negative 3. So negative 5 plus 2 is negative 3. I'm going to try this one more time. Negative 2 plus 7. Start at 0. Go to negative 2. 1, 2. That's where I left. That's where I'm at. Plus 7. So from here, I'm going to go to the right. 7. 1, 2, 3, 4, 5, 6, 7. I'm at 5. Now the next one's a little bit different. It's negative 5 minus 2. Now with this one, you have to remember something about subtraction. Subtraction is adding the opposite, or adding the additive inverse. So this would actually be negative 5 plus, what's the opposite of 2? Negative 2. So negative 5 plus negative 2. So I start at 0, and I go to negative 5. 1, 2, 3, 4, 5. And from there, I go negative 2. 1, 2. And where am I? I am at negative 7. So negative 5 minus 2 is negative 7. So now let's take a little more practice, and you can use whatever method you want. You can use algebra tiles, or you can do a number line. It doesn't really make any difference. Take a moment and sort through these, pause the video, and get back to me when you're done. Great, thanks for taking care of that. Now let's see how you did. I'm just going to put down the answers for you, and hopefully you got it right. 4 plus 3 is 7. Well, we've known that for a really long time. Negative 8 plus 5 is negative 3. Negative 2 plus 7 is 5. And negative 1 minus 6 is negative 1 plus negative 6, which is negative 7. Hopefully, that's exactly what you got. Now, there's some patterns that you should have noticed. And so when we're adding when subtracting signed numbers, we have to change the problem into addition, right? We are adding the opposites. We have to change them to an equivalent addition. Adding the opposite. Add the opposite of the second number. When adding signed numbers, if both numbers are positive, then the sum is positive. It's just a larger positive, right? If both numbers are negative, when you're adding them together, that sum is going to be just a larger negative. It's farther away from 0 on the negative side. And if one number is positive and one number is negative, then the sum can be found by subtracting their absolute values. Subtract their absolute values, and then use the sign of the larger addend. So, for example, if you were adding negative 7 plus 2, you're going to subtract, that's 7 minus 2, that's 5. But because the negative 7 was farther from 0, that's the sign you put on your answer. All right, well, now is your chance to do some practice, what you learned about integers. You're going to practice pages 41 and 42. Hope you do well on that. Get started right away, and this is in Topic 1, Lesson 6 in your packet if you don't have a book. Have a great day. Don't forget to be awesome. See you next time.